Good day, everyone. So, our today's topic in physics is capacitor, which is also known as what? Condenser. Is what? Capacitor. You can also call it what? Condenser. So, what is capacitor? It's an electrical device that's used for the storage of what? Electric energy, or for the storage of electric what? Electric charge. If you could still remember, we have what? Capacitor, and we also have inductor. This capacitor stored electric what? Electric energy. Where this inductor stored magnetic what? Magnetic energy. So the two of them, they are electric device that's used for the storage of what? Of charge. The storage of charge, capacitor, where storage of storage of charge in form of what? Of energy, where this one is used for storage of what? Of magnetic what? Field in form of what? Energy. So, what is capacitor by definition? So, the word capacitor can be defined, or is a what? Device that stored electrical what? Electric charge in form of what? Energy. Any device that's used for storage of electric charge or electric energy is called capacitor. And the capacitor consists of two plates. What? It consists of two conducting metal plates. It consists of what? Two conducting what? Metal plates separated. The plate are separated by an insulator called dielectric material. Electric what? Material. So, a device that is used for storage of electric energy is called capacitor, and the capacitor comprises of two conducting plates which are separated by an insulator called dielectric what? Material. So this is the definition for what? Capacitor. And the capacitor, it is measured in what? In farad. Let me add it to it. It is what? It is measured in what? In farad. So the next thing is what? Symbol of capacitor. Let's look at it now. Symbol of what? Capacitor. Don't forget that I said capacitor comprises of what? How many plates? Let me put it this way. of two what? Okay, then let me use this one. This is a symbol for capacitor comprised of two what? Two plates. The two plates of two equal what? Size. This is the what? The two plates of capacitor. And the each plate connected with what? Electric what? Wire. They connect with what? Electric. This line represents electric what? Wire. So between the space between the two what? Plates. This is plate. This is second what? Plate. And the space between the what? The plate, we call it what? Insu what? Insulator. And the plate, we call it insu what? Insulator. Call it insu what? Insulator. And this insulator is known as what? What? Electric what? Material. This that electric material may be paper, may be what? May be air. So this is what? The symbol for what? Capacitor. So after doing this now, the next thing is what? If capacitor is a device that we can use to store charge, how are we going to what? To charge capacitor? Let's check it. Discharging of what? Of capacitor. Charging of capacitor. Charging of capacitor. So how are we going to charge capacitor? So when capacitor is what? Is charged, is a must. It will store electric energy. But before capacitor can be charged, we must connect this device to what? To power source. And the power source there is always battery. So this capacitor down is a capacitor of neutral body, which is not what? Is not charged. And I want to what? To charge this capacitor. What I will do? I need to what? To connect the what? The capacitor we have here to a what? A battery. When it's connected to the battery, the neutral capacitor will be what? Will be charged by connecting the what? The one end of capacitor here to the one terminal end of the battery, this to another terminal end of the what? Of the battery. Let's go and check it now. So when capacitor is charging, yes, when a capacitor charge, mm, is stored electric energy. It's stored electrical what? And what? It's stored electrical energy. But before this stuff can store what? Energy, it will accumulate what? Electrical what? Electrical charge. So by accumulate what? Electrical charge on its what? On its plate. So when a capacitor charge, it stored electrical energy by what? By accumulating electric charge. Accumulating charge on its plates. with what of that with the potential with the what voltage across the capacitor increasing exponentially until it reach the until it reach the voltage across the capacitor increase exponentially until it reach or until it equal until e until e equal to EMF of power source. EMF of power source, which is what? Battery. But at this point, the charging current drop to what? To zero. Look at the diagram structure of charging of capacitor. If we have assume this is a what? Plate of what? Kappa what? Capacitor, and we connect the what? This capacitor, if you connect it to a battery source, this is the battery, note that what? Here we have what? Battery. This is the battery which serve as what? The power source. And the potential difference we have in the battery, we call it what? EMF. So in this battery now, we have what? Electro what? Motive force. And don't forget, this is the what? Plate. And between these what? Two plates, we have a dielectric what? Electric material between them. So this is insulator. We have in between the what? The plate. This is what we call what? Plate, metallic plate, And this is also what we call what? Metallic what? Plate. So if this, and again, don't forget, this thing we have here is a what? Is a wire that connects capacitor to battery. Note, before capacitor is connected to the battery, the two plates are what? Are neutral. They are what? They are neutral. Or let me do it in this way. Let me remove the battery here. Can you see it like this? Look at the plates here. Do we have any charge here? No. They are what? They are neutral. If you could still remember in electromagnetic induction and in electrostatic field, not charged by induction, I said for every neutral body, they have charge, but the charge in them, both positive and negative, their magnitude are equal. So they cancel what? Each other. That's why this body are what? Are neutral. So if I now try to what? To connect a battery to this side or to this circuit. So when battery connect to this circuit, this is the positive end of the battery, this is the negative end of the battery. But I said in this plate, we have both positive charge and negative charge. But the number of what? Of charge we have there are what? Are equal. Immediately we connect what? The positive charge to what? To this end. You will observe that the electron we have in what? In this circuit, the electron we have here will move from this circuit and move to what? To positive. So the electron move from the plate to where? To the negative charge here. When electron move from the plate and move to the what? To the positive end of the battery, don't forget this is what we call what? Battery. Move to the what? Negative end of the what? Of the battery. You will observe that absorption, we have 5 charges here, both negative and positive. So when electron is being leave the plate and move to the negative positive end of the battery, so this plate will experience a what? A, the presence of electron to experience a positive what? Positive charge. So the accumulation of the charge will take place on what? On this. So when this electron is what? Is moving inside, so it will take charge to what? The scenario will continue like this, and this will be accumulate a negative what? A negative charge. So this plate will have positive what? Charge. This plate will have a negative what? Charge. As the what? The plate is what? Is continuing to accumulate what? The charge. The potential difference between the what? The plate V. The potential what? Difference between the what? The V will be what? Will be increased as the potential difference between the electric material of the capacitors increase, the current flowing in the what? In the circuit will be what? Reduced. So I said it that what? The potential, the voltage across the capacitor increase exponentially until the current or yes, exponentially. So when the voltage between the what? The PD is increased exponentially, the current of the circuit will drop, and mind you, the what? The EMF of the what? Of the battery will also what? The what? Decrease until the what? The voltage, the what? The voltage of what? Of the capacitor, the potential difference of the capacitor is equal to what? To the EMF of the what? Of the battery. So when the voltage or potential difference of the what? Of the capacitor is equal to the EMF of the what? Of the battery, the capacitor is fully what? Charged. And the current in the circuit will be equal to the what? Zero. The current will be what? Will be drop. That is how what? Capacitor charge. And the next thing is what? Discharging of what? Of capacitor. Before we go to discharging of capacitor again, before a capacitor can be what? Can be fully charged, you will connect what? A capacitor to a power source, which is battery. When you connect the what? The capacitor to the power source to the battery, the plate that you connect to the positive end of the battery will lose electron, and the electron will move from the plate that's connected to the positive end of the battery. The electron will move from the plate into the what? Into the battery, and the current will start what? Flowing. As the electron move from the plate to the battery, the plate will accumulate what? A positive charge, and the current will keep on flowing in the what? In the circuit. So, and the potential difference between the what? And the electrical material of the plate and the capacitor is what? Will be increased, and the current in the circuit will be what? Decrease, and the what? The EMF of the battery that supply the what? The voltage out will also what? Will also what? Decrease. So until the capacitor is fully what? Charged, the potential difference would be equal to the what? Of the arrangement of the capacitor equal to the EMF of the battery, and the current we have in the what? In the circuit will be what? Will fully drop. So the next one is what? How are we going to what? To discharge capacitor. The what? Discharging of what? Capacitor. If you are talking about discharging of capacitor, is a process of connecting what? A capacitor, a fully charged what? Capacitor to a circuit with a load. If you want to discharge this capacitor now, let me remove the what? The battery and put a load there. If I put electric bulb to replace the battery, automatically the capacitor will be what? Will be discharged. All the electric energy we have in it, it will be what? It will be help me to what? To light me the what? The bulb. So as time goes on, all the charge we have in what? In it will be what? Will be decreased. So the capacitor will be what? Will be later what? Discharged. Let me write it here. Discharging of capacitor. This is a process. Okay. This is a process in which stored charge or energy, store what? Charge within capacitor is released. How is what release? Yes. Is what? Release. And this can be done by connecting what? A capacitor into a circuit without battery, or with a circuit with what? With load. Hmm? That's what this can be achieved by connecting capacitor capacitor mm, to a circuit without battery, which is power what? Source, or with circuit without battery, or with load. Load is what? Electric what? Bulb. Mm, the bulb. And how to put it? Electrical feed or electric feed surrounding it decrease, causing stored charge. Causing what? Stored charge to flow back into the mm, into the circuit through a path, which is what? Wire until the until the potential difference PD across the capacitor plate is zero. That is what the if you remove the what for discharging of capacitor, assume I want to draw the circuit like this. Let me draw a small circuit for discharging here. It's the same thing. This will go like this. It will go what? Like this. So instead of what? Of having source there, which is battery. Assume I now replace it with what? With electric what? Bulb. If I put bulb here, all the charges or charge we have on the what? On the plate. The electrical energy we have in capacitor does not stored in what? In the electric material, it's stored on the what? On the plate. So we now have what? This is charges And here we have what? The what? Electric what? Material in between. So this charge will now what? Come from here to this what? To this. And then the bulb will be what? The bulb will be lightning. And it when the potential difference of this is what? Is become what? Zero. At the end of the day, the bulb will what? Will off. So if you want to discharge a capacitor, just remove the battery and put what? The load on it. So the next thing that we are going to treat is capacitance of a capacitor. What? Capacitance. Capacitance of capacitor, or let me call it capacitance. And this capacitance, we can also call it what? Capacity. Kappa what?
Hello?
Capacity.
No, video no sir.
So what is capacitance? So the capacitance, this is divine. The what? Divine as the ratio of the quantity of charge. Ratio of the what? Quantity of what? Of charge Q on either plate of the capacitor to the PD between the plates on charge Q on either on what? Either plate, either what? Plate of the what? Capacitor to the potential difference V between the plates. See, the capacitor is just measure the capacity of the what? The capacitance is just a measure the capacity of what? Of capacitor. And then which is the ratio of the charge accumulates on the what? On the plates to the potential difference between the what? Of the plate. So mathematically, we can have what? Mathematically, we can have capacitance C to be ratio of Q over what? Over V. So this is the formula for the capacitance of a what? Capacitor. Let's take this as example. Example 1. Example what? Example 1. Calculate the potential difference across a capacitor of capacitance 2 microfarad if it if it store if it store charge of 30 microcoulomb. We are given this. We are asked to find the what? Solution. We are asked to find the capacitors. If you look at the question very well, we are given across the PD. We are looking for PD unknown. Our capacitors is 2 microfarad, and we have what? The charge, which is what? 30 microcoulomb. So you will now said using what is the formula? We are looking for what? For V. C equal to the Q over what? Over V. By applying this formula, what we use next? We can say what? V equal to the what? Q over what? Over C. Making C the V the formula. So our answer will be what? What is value for Q? Q is what? 30 microcoulomb over what? The C is 2 micro what? Microcoulomb. Microcoulomb cancel micro what? Calculate the PD across the capacitors of this. If the energy stored charge is what? 30. Yes. So cancel each other. We are left with what? 2 here in 15. We have 15 volts. That will be the what? The answer. So let us look at what? Capacitor, or no, the I'm not going to call it capacitor of a parallel plate. So after that, you look at what the connection of capacitor in the what? In the circuit.